So direct variation, we're going to be looking at the relationship between our x values and our y values. Before we do that, we're going to practice just solving some literal equations, and we're going to be solving for y. And when we get to looking at direct variation, you're going to see exactly why we're focusing on that first. So here I have 12y equals 3x. So to solve for y, I'm just dividing both sides by 12. So y equals 1/4 x, right? 3 over 12 is 1/4. Here I'm dividing by negative 10. So I end up with y is equal to negative 1/2 x. And then here, because I have the fraction, remember the fraction, we do the inverse. So instead of multiplying by 3, I'll divide by 3. Instead of dividing by 4, I will multiply by 4. Same thing on the other side. So y is equal to 60 over 3, or 20x. Just a quick review of dividing with fractions and integers. All right, so our vocabulary for this one. Direct variation is what we call a linear function when you have the equation y equals k times x, where k cannot equal 0. If k equals 0, then we end up with a vertical line on the y-axis. And so there's no equation for that. It's just y equals 0. K is called the constant of variation in this equation. So k is considered the constant of variation when you have a direct variation equation. These are what the graphs look like. The line is always going to pass through the origin at 0, 0. The slope of the line is the k value. So when k is greater than 0 or positive, we have a positive slope. If k is less than 0, we have a negative slope. When you're looking at equations, in order to determine if y is going to vary directly with x, we need to solve the equations for y. So here I'm going to divide everything by 3. So I get that y is equal to 7/3 x plus 7/3. Because I have this additional piece right here, it does not vary directly. So this is not a direct variation. There is no k value here. All right, in B, pay attention because the y term's on the other side, so we're dividing by -2. So y is equal to 5 over -2x. So this does vary directly. There's no additional piece added on. So this is direct variation. And your k value is -5/2. So all you have to do to find that is find the relationship between y and x, and you'll get that ratio in the k value. So that's how you can tell from an equation. Solve for y, and then if there's just a y equals kx piece of the equation, nothing added in or subtracted, then you have direct variation, and k is your constant of variation. All right, when you have a graph, to determine if it has direct variation, you have to see, does it pass through the origin? In example A, no. Right, this does not pass through 0, 0. So it does not have direct variation. There is no constant of variation. All right, now B is a little bit harder to see, okay, but it does go through the origin, okay? So this one does. So then we're going to find our slope. So remember, we use our ordered pairs, all right? And we're going to find the rate of change for this graph. So we're going to find the change here. So I have 1, 2, 3, 4. So -4, 1, 2, -2. Here I have 2, 1. So I need to find this relationship here. I can do 1 minus -2 over 2 minus -4. Okay, that's a little hard to read. 2 minus -4. And I get 3 over 6, or 1/2. So this is my constant of variation. The constant of variation and the slope represent the same relationship between x and y when you have direct variation. All right, in example C, this also does go through the origin, so we can find our rate, our constant of variation, or the slope of the line, by identifying our ordered pairs. So we have -2, 1, 2, 3, 4, 5, 6, -2, 7, and this one is going through the origin at 0, 0. So 0 minus 7 over 0 minus -2 is -7/2. So in this one, my k value is -7 over 2. Okay. All right, now we're going to look at how we can write our own function or equation if we know that y is varying directly. So here we know that y varies directly with x when y is 15 and x is 27. So what we have to find is we have to actually find our k value. So we know that y equals k times x because that's what this piece right here tells us. In order to figure out what our k value is, we're going to substitute the y and x values into our equation and then solve for k. So I'll have 15 is equal to k times 27. I'll divide both sides by 27. And I get that k is equal to 15 over 27, or both can be simplified by a factor of 3, so 5/9. So my equation is y equals 5/9 times x. So now I have the information I need to actually finish this question. They wanted me to write the function. This is the function that models the variation. Now I have to find my y value when x equals 18. So I'm going to evaluate the function when x equals 18. So y equals 5/9 times 18. Simplify. I get that y is equal to 10. Now we're going to look at what if you're given data in a table. Can we determine if they vary directly? And if so, what is that constant of variation? So here I have a difference of 3, and here I have a difference of 3. Here I have a difference of 9, and here I have a difference of 9. So I am seeing a constant rate of change. So this tells me it is linear, right? Because my change is the same, it's linear. Now I need to see if it varies directly. So this means that when I divide y divided by x, is it the same each time? So what I'm trying to find now is, okay, when I do this, if it's the same each time, then I'm good. So if I have 3 over -1, that's -3. -6 over 2 is also -3. And then I have 15 over 5, and that's a +3. So this does not have a direct variation. So it does not have direct variation. And even though, see, like the difference here is 9, it's actually a -9. Sorry, I didn't even realize this is a -6, so this change is not 9. this change is 21. So it's not linear, does not have direct variation. There's no constant of proportionality. It's a non-linear function. Sorry, so this is not linear, does not have direct variation. The next one. So if I have 14 over 7, I get 2. 18 over 9, I get 2. Negative 8 over negative 4, I get 2. Because these are all the same, I do have direct variation. This is my k value. So my equation is going to be that y is equal to 2x. So what happens if it was not direct variation? If I tried to divide, I would not get the same thing each time. So we would not end up having direct variation. All right, what about in a word problem? It says weight on the moon, y, varies directly with weight on the earth, x. A person who weighs 100 pounds on earth weighs 16 and 6/10 of a pound on the moon. What is an equation that relates weight on earth and weight on the moon? And then how much would a person who weighs 150 pounds on earth weigh on the moon? So we need to find our k value. It tells us that it varies directly, so we know there should be this relationship, right? So y definitely equals k times x. We know that when x is 100, y is 16 and 6/10. So we can substitute those in and then solve for k. So our k value is going to be 166 thousandths, or 0.166. So now I can use that value to find the weight of a person on the moon if they weigh 150 pounds on Earth. So y is equal to my k value times their weight on Earth, and they would weigh 24 and 9/10 pounds on the moon.